So welcome guys back to the video. In this video we are going to study about subnetting. So this is part 1. So before going further like learning about subnetting, let's have a recap from IPv4 addressing part 2 video. In that video we just found out like how to find out maximum number of hosts. So that is like 2 raised to n minus 2, and then network address, broadcast address, first usable address and last usable address of a network. So let's take an example to refresh us. So we have two routers connected in two different locations, that is one in San Francisco and one in New York. So we have taken a network that is 203.0.113.0/24. So /24 subnet and .1 and .2 IPs for that. So how much usable addresses will be, like total number of addresses will be there? So like 2 raised to 8, so that is nothing but 256, and then usable host will be like 254, like minus in network and broadcast part. So what the network part will be, like network address will be like 203.113.0, the network ID itself. The broadcast will be like the last IP, that is like 255 over here, and the first IP address will be like .1, and then second will be like .2. But don't you think like out of 256 there are like 254 usable addresses, and then we just have a requirement of 2. So basically like 254 minus 2, that is like 252 addresses are being wasted. So the solution to it is like the CIDR. So CIDR is nothing but the classless inter-domain routing over here. So the IETF, that is nothing but Internet Engineering Task Force, introduced CIDR in 1993 to replace classful addressing system. So with CIDR, the requirements of class A, that is /8, class B, that is /16, and class C, that is /24 were removed. So this allowed a larger network, that is a large network, to split into smaller network. So and then this smaller network are called subnets or subnetworks over here. So let's see with an example. So again let's take an example, like two routers connected to this and it has /24 subnet. So what's the formula for finding how many usable addresses are there in each network? So that is nothing but 2 raised to n minus 2 usable addresses. So that is nothing but like 24 /24 means like first 24 bits belongs to the network and rest 8 will belong to the host. So let's calculate how many usable host will be there in /25, /26, 27 until like /32. So let's calculate over here. So let's go to our screen over here, and then yeah, so I'll cast over here quickly, and then let's see how many usable hosts are there. So I hope so my screen is visible over here. So what's the address? 203.0.113.0/24. so in /24, as we saw, 32 minus 24, that is nothing but 8. So 2 raised to n minus 2, that is 2 raised to 8 minus 2, that is nothing but 256 minus 2, that is nothing but 254 usable addresses, and then out of that we just need 2 for point to point connection. So that is nothing but 254 minus 2, that is 252 addresses are being wasted. So let's see like how many addresses in further subnet we find out. So we go for /25 subnet. So 32 minus 25, that is nothing but 7 over here. 2 raised to n minus 2, that is 2 raised to 7 minus 2, that is 128 minus 2, that is 126 usable addresses. So we just have a requirement of 2 addresses. So 126 minus 2, that is 124 addresses are still being wasted. So let's go to a more smaller subnet, that is /26 over here, /26. So 32 minus 26, that is nothing but 6, and 2 raised to n minus 2, that is 2 raised to 6 minus 2, that is nothing but 64 minus 2, that will be 62 usable addresses, but we have requirement of only of 2 addresses. So 62 minus 2, that is like again 60 addresses being wasted over there. So let's go to again more slash 27 network over here. So that is 2 raised to n minus 2, 32 minus 27, that is nothing but 5. So 2 raised to 5 minus 2, that is nothing but 32 minus 2, that is 30 usable addresses over there. So if you have 30 usable addresses, so like we have a requirement of only 2, so that is like still 28 addresses being wasted over there. So let's see again in like slash 28 network over there. So 203.0.113.0. So in this network, so how many n bits will be there? So still 4. So 2 raised to n minus 2, that is like 2 raised to 4 minus 2, that is 16 minus 2, so that is 14 usable addresses over there. So we just have a requirement of 2, so like we'll just see like how much addresses are there. So again 12 addresses are being wasted over there. So 203.0 will, let's go to more smaller subnet, that is slash 29, 32 minus 29, that is 3. So 2 raised to n minus 2, that will be like 2 raised to 3 minus 2, that is nothing but 8 minus 2, that is 6. So we are getting closer and shorter. So 6 usable addresses, but we have requirement of only 2. So 6 minus 2, that is like 4 addresses are being wasted again, right? So let's go to more smaller subnet, that is slash 30 over here, that is 203.2.113.0. so 32 minus 30, that is 2. 2 raised to n minus 2, that is 2 raised to 2 minus 2 is equal to 4. 4 minus 2, that is 2. 2 usable addresses. I think this criteria satisfies our requirement over here. So 2 usable addresses, so 2 minus 2 is like 0 addresses being wasted. So slash 30 is like the ultimate really good solution for this subnet. So but what if we go for like slash 31? Is it possible, do you think, guys? So let's give a shot for this. So 32 minus 31, that is 1. 2 raised to n minus 2, that is 2 raised to 1 minus 2, that is 2 minus 2, that is 0 usable addresses. So do you think like this condition is possible for slash 31, like 0 usable addresses? So this is like an exception in Cisco, that is that this can be just being used slash 31 if you have point to point connection. So let's go to my screen again over here and see. So I have taken like slash 31, and then you see for 30 it's like 4 usable, 2 usable addresses. But if you go for like slash 31 and configure on a router's interface, so IP address 203.0.113.0 and then 255.255.255.254, that is like slash 31. So it gives a warning. So using slash 31 mask on point to point interface, so be cautious. So it just allows you like to use on point to point interface. So that's all for this video. I hope the subnetting part is being clear for you guys, and then in next video we'll just see more examples and more test case scenarios, and we'll do some more calculation and hands-on configuration. So that's all for this video. Thank you. Stay tuned for the part 2.